Hey guys, I hope you're doing great. Let's look at today's question, which is Leetcode number 278, first bad version. So it's an easy question, but it is an interesting question. I'll tell you why. So you may read the full question problem description. I'll explain to you in summary that we are given a version history of a software or a code, and each version is labeled with a number in increment order up to n, right? And there is a version in this history which was a bad version release. So once the software was released with a bad version, subsequent versions also is now buggy or bad. So you may look at this version history as this is a good version, this is a good version, good version, good version, and now we are starting to see bad versions of the software. Now you have to find the first bad version in this version history. Okay, and you are given an API called isBadVersion where you provide a version number and it will tell you whether it is good or bad. Right, and we need to minimize the number of calls to the API. So what we can do is we can iterate just through the all version numbers and call the API is bad version for all of the versions, n versions, and we have the solution in order n, right? But we can optimize this solution. What we can do is whenever we have this pattern where you get a number line, right, and you have the answer as tick 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 tick, and suddenly you get wrong answers, you can generally do a binary search on this. You start from low and high as the bound, and you just partition the array into two equal parts, take the middle, and find out what the middle is. So if middle is a good version, then you know your first bad version lies from middle to high, right? So you just need to search in the later part of the array, and you can totally discard the first part of the array. And in this way, what you'll do is in each call, you made the array into one fourth into half. So basically, what you're doing is you are making log n base 2 calls. We can code this binary search in a very simplistic way. The reason why this question is very interesting because this sort of pattern where you need to search an answer within a range of number is very frequent in coding interview problems, and you need an eye to recognize these sort of problems. So first let's look at the code, and then after the code I'll tell you different questions with such pattern for binary search. So I'll just tell you we'll look at an aggressive cow questions, and this is on Spodge, which can be used using the binary search technique, and Harry Potter and the Golden Snitch. And this is a very long question if you read the question problem description. But again, all it boils down to whether you can recognize this problem and recognize that this is binary search or not. So let's code the binary search and then come back and look at these two problems, how to solve these two problems. Okay, so I'll define my answer equals to n here because this is the last version. Low equals to 1 for binary search, high equals to n. While low is less than equals to high, finding the integer mid. Now if is that version m, then our answer becomes m, and the answer lies on the first part, first subpart of the array. So our high becomes m minus 1, and low becomes 1. Okay, fine, this works. Now let us get back to our drawing board and discuss those two problems which I have mentioned, aggressive cow and Harry Potter and the Snitch, and see the similarities between that question and this question. And how can we recognize those patterns in an interview problem? So you have a long barn and there are n stalls and you have c cows and each cow, one cow, can be put in these stalls. To prevent the cows from hurting each other, we want to assign cows to the stalls as the minimum distance between any two of them is as large as possible. So if I have two cows, I would probably want to put them on the different end of the barn. And if I have three cows, then I want to put them in different end and one cow here, right? And if I have like five cows, I want to place them like equally distanced onto the barns. This question is very interesting because you can get into a greedy sort of mood and try to solve this question by finding right placement. Or you can even get into a search sort of a mental state where you want to put the first cow on the first end, then put the second cow to the maximum distance, then finding a stall which is equidistant from first and second, and putting the third cow between those two stalls. Then for the fourth cow, you would find a stall which minimizes the distance between 1 and 3, or minimizes the distance between 3 and the second cow. And you decide to put the cow 4 here, right? So this is like a search and greedy algorithm. But this question can be easily solved if you think in terms of binary search. And if you are given a function, say put cows at distance m. Okay, if this function can tell you whether we can put cows at m distance or more, and I can put them into these stalls, then what I can do is, this is actually my answer line starting from 0 to infinity, or say n here, the largest coordinate xn, and I can search on this line for each m here. I can do a binary search and call put cows at distance m, and this will return true or false. So I'm binary searching on the answer, just like I binary search for the bad version, and instead of calling is bad version, I'm now calling put cows at distance m. So in this way, so I would what this answer timeline would look like is, if I can put cow at minimum distance, and this is my answer, then I can also put cow at lesser distance. But I cannot put cow on more distance after this. So this line would look like this. So I can easily do a binary search on such timeline. Now let's look at the Harry Potter and the Golden Snitch. So I have put in the description the links for these two questions, so you can go to the question and read the whole problem statement if you wish, but I'll summarize it for you. So we have the golden snitch, and this is my Potter flying to catch the golden snitch. This golden snitch flies through various points starting from x0, y0, z0, and goes through something like this, and ends up at xn, yn, zn. Right? My Harry Potter is at starting position, say px, py, and pz, and each moves with a speed of velocity of vs, and Harry Potter moves at velocity of vp. Now we need to find if Harry Potter can catch the snitch at any of these points given in the problem or not. And if he can catch it, what is the minimum time he can catch it? If I draw the catch time, if Harry Potter can catch the snitch in time t, can catch the snitch, right? Then he can also catch the snitch in t plus 1, t plus 2, and so on. He cannot actually catch the snitch on t minus 1. So these all will be wrong. So again, our answer line looks something like this. So there are two partitions where one is good and the other is bad, and we want to find the least one which is good, right? So if I provide you a function can catch snitch and supply this with a time, and this returns me true whether he can catch the snitch or not, and a false if he cannot catch the snitch. Then what I do is I'll binary search on time, and I can get the answer, just like I binary search on the versions and got the answer. So I think it's more important to see patterns in these questions which are on Leetcode, and try to learn how can these patterns be molded to form different scenarios, and we need to recognize those scenarios when we go into an interview. So thanks again for watching, guys. Please like our video if you do, and subscribe to our channel for more videos like this. I hope you had a great time. Thank you so much for watching.